The political framework for energy policy has changed. The new consensus represents a challenge for Europe's energy industry. Researching and developing renewable energies are tasks which have been given the highest social and political priority over the last decade. And yet, despite extensive government support, these alternatives have their limitations when it comes to providing a constant supply of energy for industry. And manufacturing the necessary technologies also consumes large amounts of raw materials and energy. The decisive factor in using these renewable energies is the restructuring of the energy supply network. The vision is the intelligent grid, a gigantic task for the engineers of the 21st century. Prosperity and mobility ensure peaceful coexistence in a united Europe. Only the combination of commitment and advanced planning will enable people to survive even times of darkness relatively unscathed. Traditional energy sources will gain a new significance, but only if the efficiency of their combustion processes can be significantly increased. The thermal utilization of renewable raw materials has also developed into a new economic factor. Besides other materials, waste wood from the forestry industry is predominantly used at the Kerava site in Finland. The energy produced by this power plant is transported in a district heating pipeline to a brewery 2 kilometers away. Hot water flows through a thermal high-performance steel-cased pipeline at a temperature of 200 degrees centigrade and a pressure of 16 bar. The rocky terrain guarantees the pipe is laid on a secure foundation. After all, the system is expected to operate without disturbance for decades to come. Digging the trench for the underground pipeline through rock naturally involves a great deal of work. It is adapted to the topographical conditions and literally nestles into the surface contours. The differences in expansion of the hot inner pipe and the cold encasing pipe have to be considered right from the planning stage of a district heating project. The required compensation is defined in the expansion concept. Here in Kerava, compensation is provided by a combination of thermal pre-stressing and natural expansion. The district heating concept in Kerava is one of the best examples of advanced planning management in Europe. The name FW-FERNWÄRME-TECHNIK stands for reliability and durability of thermal high-performance steel-cased pipe-in-pipe solutions. Decades of experience and extraordinary commitment are the trademark features of this medium-sized company from Celle in the heart of Lower Saxony. The success of the district heating specialists is rooted in their cosmopolitan approach and contacts to international customers. In Copenhagen, for example, over 6 kilometers of steel-cased pipes run through a tunnel system under the harbour and the inner city. Steam at 300 degrees centigrade provides the town with a clean and reliable source of district heating. Working in environmentally sensitive protected areas is subject to particular regulations. District heat pipelines must be laid trenchless underground, i.e. they must be earth-laid. This is done by using the horizontal directional drilling technique. Steel-in-steel pipelines can easily withstand the mechanical forces they are exposed to during the laying process. Two 410-meter pipelines make up the Schunter crossing in Braunschweig. The 50-centimeter diameter pipe is pulled into the underground borehole meter by meter with a tractive force of up to 100 tons. Just a few hours later, phase 1 is over. The pull-in operation for the first steel-cased pipe has been completed. The pipeline itself is assembled on-site. Extensive examination of all weld seams guarantees the job done is free from defects. The X-ray documentation provides an uncompromising evaluation of the welder's work, and so provides great confidence for everyone involved. The GFK insulation on the joints is also applied on-site. The moment has arrived. The second pipe goes into the borehole smoothly and without any trouble. And to keep things running smoothly, the drilling fluid used is bentonite, which also supports the borehole. So this flush drilling technique is extremely effective all round. In the pipeline itself, the inner pipe would later expand. But thermal pre-stressing with hot steam ensures that the inner pipe is expanded before commissioning. Now the encasing pipe is extended by adding 2 half shells. After the inner pipe has cooled down, the pre-stress forces are absorbed by the encasing pipe. The inner pipe will not expand anymore. In conclusion, we can say that horizontal direction drilling enables district heating pipelines to be laid in a way that is environmentally compatible. There are around 100 highly qualified people working at FW-FERNWÄRME-TECHNIK GmbH who can refer to an extensive experience of international projects. In the manufacture of steel-in-steel pipes, experience above all is of inestimable value. For instance, in corrosion protection. The polyethylene that is heated with a blowtorch is processed with extreme care and attention. Ensuring clean breaks on steel edges is a basic precondition for weld seam preparation. TIG welding stands for tungsten inert gas welding. With this precision welding process, the quality of the root pass is especially high. This is important because all later internal filling layers are built up on this first internal weld layer. A ceiling-mounted radiant heating system with heat recovery keeps air movement in the production plant to a minimum. This is important as it ensures there is always a consistently high concentration of inert gas at the weld seam. This also applies to rational metal active gas welding, or MAG welding, when filling the weld seams on steel-cased pipes. Temperature and pressure are the essential criteria in selecting the materials. Only specially selected steel pipe grades are used. The standard length is 16 meters. The roller bearings around the pipe are designed to deal with the pipes being laid without compensation. 2 of these roller bearings are much better able to withstand the high lateral pressure. Despite the fact that the mineral wool insulation is largely prefabricated, it has to be cut manually to fit precisely around the bearings. This is done with the help of templates. Reliable material selection guarantees an extremely long service life for the district heating system. The heat insulation is fixed by spot-welded steel strips, while the completely prefabricated inner pipe is being pulled into the encasing pipe. Manufacturing pipe bends and elbows is an art in itself, because art comes from ability. Especially the making of an encasing pipe elbow is a technical masterpiece. The Holiday high voltage spark test on the external insulation is carried out using 25,000 volts. This test is also carried out to ensure the highest possible degree of manufacturing quality. The precise marking of each unit enables them to be positioned correctly on site in accordance with the installation plan. The waste incineration plant at Ham can process up to 295,000 tons of waste every year. The extraction of excess heat means that 120,000 megawatts of energy per year can be fed into the grid through the new district heating pipeline that runs under the River Lippe and the Datteln-Ham Canal. Two 412-meter steel case pipes, welded together and tested on site, are laid using the horizontal flush drilling technique. These will later be connected up to bonded systems. The aerial pictures clearly show the pipeline route below the two waterways. First, a pilot hole is drilled. The drill head is fitted with a navigation system and a three-dimensional control. The expanding tool, the reamer, clears the borehole. The back and forth movement of this high-pressure spray nozzle flushes the earth which has been loosened by the bentonite out of the borehole. Now the pipeline is pulled in. The borehole needs to be 1/3 wider than the encasing pipe diameter. Bentonite swelling characteristics ensure that the pipeline is tightly embedded. The mobile drilling unit set up in the port area drives the pilot drill head forward hydromechanically. The asymmetrical drill head transmits its position to the drill controllers via the signal cables installed in the drill pipe. This controllable horizontal directional drilling technique is known as HDD. HDD installation technology is being used increasingly all over the world. And the bentonite slurry can also be recycled without any problems. An important day. The pull-in operation for the first section is about to begin. With the help of roller blocks, the heavy section line can be pulled across the Lippe floodplain dam with very little resistance. The HDD technique enables up to 2,000 meters of pipeline with a steel case diameter of up to 1,20 meters to be laid in one piece. There are no compensation elements within the drilling area. The planner's tasks include finding a suitable area, determining the pipeline route with start and target pits, and as-built measuring. FW steel case district heating pipelines laid in HDD are an invisible yet extremely long-lasting, high-performance thermal energy source. Even for FW-FERNWÄRME-TECHNIK, this is an unusual sight. A large convoy of trucks carrying steel-cased pipes is leaving the works in Celle. Their destination is in the west of Europe, just outside the city of Amsterdam. A building site of gigantic proportions. The flat polder landscape around Almere was completely drained only a few decades ago. On the outskirts of Amsterdam, a huge residential area has sprung up to house the constantly growing conurbation. To secure the energy supply, a district heating pipeline is being laid right across the IJsselmeer. The Diemen power station is 8.5 kilometers from the delivery point in the port of Almere. An enormous task for the internationally experienced pipeline constructors and district heating specialists from Celle. Over 1,000 units, or to be more precise, 17,000 meters of district heating steel case pipe have to be produced and delivered just in time. The 16-meter construction units have to be welded together into 500 or 700 meter lengths on site. Machining the steel edges is the first step in preparation for the welding process. Protected from the elements in special tents, TIG welding the root passes is carried out first. Downhand welding is a rational process used for fill and cover passes. The filler material, or in other words the electrode, flows directly into the seam, requiring great manual skill from the welder. The joints welded on the building site need to be treated with passive corrosion protection. With great care, each seam is insulated, and of course, not only when there's a camera around. Seen from the air, it becomes very clear why a district heating pipeline can't be laid above ground through a cultural landscape. The existing power plant and the new block extract the 135 degrees centigrade district heat for Almere. The crossings over the dikes and shipping channels have to be laid using the HDD method. With HDD lengths of 2 × 520 meters, 2 × 690 meters, and 2 × 310 meters, this is a project of superlatives. To create space, the prefabricated sections are pulled to the lakeside area over rollers shortly after their completion. Before being floated, the entire passive corrosion protection on each pipeline section is checked thoroughly by means of a holiday high-voltage spark test. Supported by the excavator, the tug pulls the approximately 200-ton section into the water. The sealing caps placed on both ends enable the pipelines to float. The sections are only pulled into their final position just before the installation process begins. On the power station side, the HDD borehole exit opening is in the water. This enables the pipeline to be pulled in smoothly underneath the dike in only a few hours. And so the second pipe also reaches its destination on the power plant site. A truly Olympian achievement. Though there are of course no medals to be won here, the project information event for internationally operating district heating experts arouses great interest. The highlight is the on-site guided tour on the IJsselmeer. Preparations for the trench are already in full swing, and on the floating platform, the individual pipeline sections are being joined together. Here, the mechanical pre-stressing of the inner pipe against the encasing pipe is carried out by using a hydraulic pre-stressing device. The result? Both flow and return pipe have been successfully completed without compensators. The horizontal directional drilling method is also being used to cross the 19-meter deep shipping lane. The use of district heat extraction significantly increases the efficiency of power plants. In Europe especially, commitment and advanced planning should be the incentive to drive the development of new projects and to unleash unused potential.